Hi friends, welcome to another episode on the operating systems. So today we just look at what a computer system is made up of. Let's just check the organization of a computer system. So computer system contains many components as you can see in the figure. So it mainly consists of a processing unit, central processing unit (CPU), and then it is connected to various components like memory, and the memory can be read-only memory (ROM) or random access memory (RAM). Both of them are put on the motherboard, and at the back end where we have secondary memory. For that we will have various disks, so it's a hard disk and other disk like compact disk, CD, and all such things. So for uh, having proper interaction with the disks, we have something called a disk controller. Then to make sure that the human interacts with the machine more efficiently with minimum troubles. So many I/O devices are attached to the system, and to ensure that all the I/O devices work more efficiently, then we have controller for I/O devices. The I/O devices may be a keyboard, monitor, display, printer, and many more. Now the question is how they are interconnected. So on the motherboard, mainly we find three types of units. One, the central processing unit, and the second one is the memory, and the third one is the one which is connected to the outside world through I/O. Now the CPU has to interact with the memory and various devices, and for that we make use of a bus system. And in the bus system, mainly on the motherboard, there are three types of buses we have. One, the data bus, which is used to transfer data from one unit to another unit. And then there is an address bus which identifies which of the devices is to be used. So the address will tell which device to use, and in that device where or which part of the device to be used. Or if you are talking about memory, then the location of the memory is represented by the address. So part of the address decides which device we are working with, and other part of the address talks about the internal locations. So overall, the address bus is going to define which part of the system or which part of the component is being interacted with the CPU. And finally, we have something called control bus, and this control bus is used to decide what type of activity is going on. Is it the processor wants to write onto the memory or wants to read from the memory? And if it is wants to write to memory, in what format it wants to write? If it is trying to read, in what format it is trying to read? If it is trying to read from the keyboard or trying to read from the mouse, or if it is giving instruction to the printer, all these are controlled by the control bus. So if we are trying to uh, write some data onto the memory, then what data we want to write onto the memory, that data we put it on the data bus. Then we decide where we want to write it on the memory, the location where the data has to be written. So the address, so made up of two components. First component talking about which uh, device is to be used, and the location in that device. So these two together form the address, and this address is put on the address bus, and then finally control bus will initiate which action to be taken. So here we are trying to write onto the memory. So CPU puts data onto the data bus. CPU tells where to write. So put the address onto the address bus. And finally CPU says that the activity to be done is to write. So the write message is created onto the control bus, and because address bus contains address of the memory, so appropriate memory gets ready for the action. Data is ready on the data bus, and finally control bus will give a control signal that whatever is there on the data bus should be written onto the memory, and the memory component knows where to write through the address bus. Same way, if we are talking about reading the keyboard, then first thing is address bus will inform that we want to interact with the keyboard. So the address of the keyboard is put on the address bus, and then control bus says that it is a read action. So the keyboard is active because of the address bus, and read action is initiated by the control bus. And when any key is pressed, the details of the key pressed gets into the database, and through the database controller understands that what is being typed. So if CPU wants to know what key is being pressed, then it has to first enable the keyboard, giving a address of the keyboard, and then giving appropriate control signal to enable the keyboard, and then finally wait for a key to be pressed. And when a key is pressed, then the data bus gets the data, and IO device like that keyboard will send a control signal saying that one key is being pressed and the data is put on the data bus. So this information goes to the CPU. Until then, CPU will be waiting for some key to be pressed. The moment a key is pressed, the IO device or the keyboard will send back a control signal saying that a key is pressed and the data is on the data bus. So CPU is now free to read the data from the keyboard. So these all activities take when we are working with the IO devices with the memory, and how CPU interacts with the memory and various IO devices. And for making all these things possible, one option is if we are looking for keyboard to read. So there is a lot of speed disparity. The processor is working in nanosecond speed, and the one who is operating with the keyboard a human is working with a response time of a best case is in terms of milliseconds, even if he types the fastest way, then between two keystrokes, we will have some milliseconds of delays. And these milliseconds of delays, when you compare with the processor's speed, which is working in nanosecond, so it will be millions of cycles of the processor. It has to wait between two keys, and how this can be improved instead of making the processor wait for keys to be pressed. So what we can do is we just tell the keyboard just to inform me whenever a key is pressed. So instead of keeping the keyboard ready for working as we did in the previous discussion. Now what we can do is instead of making CPU wait for keyboard, we just give an instruction to keyboard that whenever any key is pressed, you just tell me. So what should I do then? What should CPU do then? So let the CPU continue working whatever task is available for that CPU to do. So millions of time frame is available between two keystrokes, and that millions of cycles of the CPU can be used for some other execution, some other activity. So what we can do now is let the CPU continue working with its current activity, and in the background let the keyboard be waiting for the human to press the key, and anytime a human presses the key, we want the CPU to know that this key is being pressed, and if that pressing of the key makes any sense to the CPU, then CPU should take appropriate action and all that. But how to make uh, CPU to know that a key is pressed. So there comes what we call an interrupt. So interrupt is a process where these slower devices and all that can interrupt the CPU whenever some special event happens, like a key is pressed. So whenever a key is pressed, the CPU gets interrupted and says that a key is pressed. And if pressing of that key means something to the CPU for a given process, then it takes a corresponding action on that. And if it doesn't make any sense, then it just neglects the pressing of the key and so on. So, for example, if just a window screen is on and you try to press some keys, it may not make any changes in the system, but same thing when the screen is open with some Word document, and in the Word document is in edit mode, then whatever key you press, it gets displayed, and for that, what is required is the CPU should know what key is pressed, and then it should inform the display system to display a particular character at the prompt and all that. So this activity takes place when we are working with slow devices and all that. The same thing is possible with other things. So interrupt is mainly used to interrupt whatever process is going on, whatever CPU is currently doing, and we just try to interrupt it to make some special events to occur. So whenever we want some special events to occur, we try to interrupt the CPU, and the CPU will decide if that special event is really special in the current situation. If so, it will do some special actions. Otherwise, it may just neglect and continue whatever it is doing. So looking at the figure, we can see that the interrupts can be of two types: a hardware interrupt, software interrupt. So the hardware interrupt, as just discussed, it is coming from a hardware like a keyboard, mouse, or and all that. So if I just move the mouse, my this icon is moving, the pointer is moving. So to make sure that the pointer moves, the whenever the mouse is moved, then a message goes to the CPU saying that mouse has moved, and the CPU should respond if required and make the position of the mouse change as per the instruction getting from the mouse and so on. So that's what we call hardware interrupts. There are two types of hardware interrupts. One is coming from the external like IO interrupts, like coming from the keyboard or the mouse and all that. And there is another interrupt which is internal interrupt. That is something like exceptions when you are trying to work with some address and all that which is not allowed, then exception is raised, and because of that the computer or the CPU has to stop execution. So that is also comes under the hardware. And that's external. Yes, just as discussed, keyboard, mouse, and all that are the hardware components that are basically working very slow because it's mainly human related actions, and human reaction time is in milliseconds, and computers working is in nanoseconds. So there is a lot of disparity between the two speeds, and not to waste the precious time of the CPU, let's allow CPU to continue working, and whenever input from the human is available, let us interrupt the CPU and make it work for a special purpose and all that. On the other side, there are something called software interrupts. They are generated by the program. So here, program generates user-defined programs, and user-defined interrupts are there, and these are useful whenever we are calling system calls. So system calls, whenever being called, we have to stop the execution of whatever currently we are doing and then make some changes like required while writing device drivers and all that. So basically, the interrupt is used to signal some event being uh, if a particular event occurs, we want to make a CPU to be aware that such an event happened. So to inform the CPU, we do have something called interrupts. They are of two types: software, hardware interrupts, and these are the signals for event handling. So that's all about the system organization as of now, and many more issues to be discussed. So let's get to the another concept in the next session. So till then, take care. Bye.